Hi. Okay, let's talk about the optimization problem where the cylinder is inscribed in a sphere, right? Where's the cylinder is inscribed in a sphere, all right? So there's the given solid cylinder of radius r is inscribed of radius 10 cm, means the sphere is a fixed one, okay? The sphere is fixed and this radius can be changing. Alright, means that the cylinder can be changing of size, can be small radius, right? So the height can be changed, so the radius also can be changed, but the sphere is fixed. It's fixed with the radius of 10 cm, right? The radius of 10 cm. So such that the circumference of the end of the cylinder touch the sphere, okay? It's touch the sphere, so it's inside the sphere. So there is a cylinder. So then they ask you to find the height of the cylinder in terms of r. Oh, they want you to relate the height of the cylinder to r. Alright, means that the height of the cylinder in terms of r. Right? So usually if you see that here will be 10 cm, so here also will be 10 cm, right? Here will be 10 cm, because why? This is a radius of the sphere, alright? As this one, the corner here is touching the circumference of the surface of the sphere. So now, then you can try to see that h, right? H. So of course, if you know that this is the radius, right? This is the radius. If this is a circle, if you look at this in 2 dimensions, this is actually a circle. So if you draw to here, this point, this is a chord, right? It's a chord, a circle. Let's say you have a circle, you have a chord of any size. So if you draw from the center a perpendicular line, draw from the center to this chord, you will divide them to 2 equal part here, right? So it means that the length of this and the length of this are of the same. So it means that I can say that the length and this length are the same. So which is the height, right? So because of they have the same length, so here you have h over 2. H over 2, and this one also h over 2. So by looking at this from here to here, this is a 90 degree. Then you can see there is a triangle here, the right angle triangle here. I'm going to draw out here. The right angle triangle here will be represented by r and h over 2, and this is 10 cm, right? So then I can get the relationship between radius and h by using Pythagoras theorem. Alright, Pythagoras theorem. So means that the h over 2 to the power of 2 plus with r to the power of 2, the square of the two side is sum is the same as the hypotenuse square, right? So the question is asking you to height of the cylinder, the height of the cylinder in terms of radius. So and I can see that h over 2 to the power of 2 is equals to 100, right? 100 minus with r to the power of 2. So the square, so you go over there, if you square root both sides, and this is the height, so there are no positive negative as you square root, so it's only positive value. So 100 minus r square, height is positive. So then you have h to be 2 square root of 100 minus r square. So this is the relationship between h and r, or I can say h in terms of r. Right? So you have h equals to 2 square root of 100 minus r square. So following the following question, they require to show that the curved surface area of the cylinder, right? The curved surface area of the cylinder is given by 4 pi r. The curved surface area means that the curved surface here. So which is, as you know that cylinder, right? The cylinder, you can open up to 2 circles and a curved surface area, right? And this one will be your r, and the radius here, the length of the circumference here will be the side, right? The base, right? So this one will be 2 pi r, 2 pi r, and of course this is your height, right? As you open up, this will be your height, and this one will form the side here. So 2 pi r h. So it means that this is pi r square. It's made up of top and down, pi r square pi r square. So, and this is 2 pi rh. 2 pi rh, because the question is saying that the curved surface, this is not the curved surface, and this is your curved surface, means this one, this is your curved surface. So where if you go and fold it, you will get a curved surface here. So then this curved surface, we set the area to be 2 pi rh, right? 2 pi rh. This is not involved in the question is not mentioning pi r square and pi r square. No, it's just the side, okay? The curved surface here. So A equals to 2 pi r, and h already in term of h, you know that is 2 square root of 100 minus with r to the power of 2. Then you have getting A in term relate to r, means that the curved surface area relate to the radius of the base. So be 4 pi r square root of 100 minus r to the power of 2. So this will be the formula, alright, the model, the A, the formula of the curved surface area in term of r. Alright, so now we have A equals to 4 pi, alright, you know that A is in term of r. So they want to find the maximum, the maximum value of A. So means that they said that the A is maximum when the r is 5 to the square root of 2. They're asking you to show that when there is the A is maximum is when the r is 5 square root of 2, and hence find the area of the side, all right, of the curved surface. So now, then what we're going to do now is I'm going to differentiate this, right? Yeah. So you have to find dA dr. So before you find dA dr, I think for this case you have to apply product rule, as r is here and r is inside the bracket. So 1 minus 100 minus r squared to the power of half. So I'm going to apply uv, right? Uv. So differentiate. So dA dr u, right? U, you have 4 pi r, all right? U, v prime. Okay, differentiate this v prime. So you have half, right? Half 100 minus with r to the power of 2, negative 1 over 2, right? Minus 1, and differentiate. You have negative 2r, right? Using chain rule. So you have very familiar about this. So now secondly, we have to v u prime. Not finished yet because this is u v prime. Now it's v u prime, your v. So 100 minus r to the power of 2 v u prime. Differentiate 4 pi r, right? Differentiate 4 pi r, you have 4 pi. You have 4 pi. So later you know that 2 and 2 cancel off. So you will have 4 pi r, right? If you look at, be careful about this. 2, negative 2, you have negative 1, negative r. Negative r, and this one become negative 4 pi r square, right? 4 pi r square. And this is negative 102, so you can bring it down, becomes square root of 100 minus r to the power of 2, all right? Then plus with 4 pi 100 square root, okay? This is square root 102, square root 1 minus r to the power of 2. So then I think it's better for you to equate the denominator, as this is 1. So I'm going to multiply this with square root of 100 minus with r to the power of 2, and multiply with square root of 100 minus r to the power of 2. So okay, to equate the denominator, so my dA dr is everything divided by square root of 100 minus r to the power of 2, right? So I have combined the denominator. Now I'm going to deal with the numerator. So negative 4 pi r to the power of 2 plus with 4 pi. You have 4 pi here, and these two, square root of a multiplied with square root of a, this is identical, so you can get back 100. 100 minus r to the power of 2. Alright, so finally you have simplified. So you are getting negative 4 pi. So this is, you have 4 pi. I think I factorize the 4 pi, is easy for me to see. So if I take out the 4 pi, okay, then after you take out the 4 pi, you have negative r to the power of 2, negative r to the power of 2, plus with 100 minus r to the power of 2, divided by square root of 100 minus r to the power of 2. So rearrange, then my dAdr will be 4 pi. Inside we have 100 minus with r squared minus r squared, we have minus 2r to the power of 2, right? Minus 2r to the power of 2 divided by square root of 100 minus r squared. I think this is the best. So okay, I leave it in this form. So this is my dAdr, right? So as you know that after you're differentiating this, you have to equate d to 0. Okay, of course there is a second derivative test here, but for this case, if you use second derivative test, you will end up with differentiating very tired and very tedious. So I think I'm going to use first derivative test. Okay, so now at first I want to find the optimum value first. Okay, the relative extremum value first. So I need to equate this to 0. Alright, let's see. Alright, let's continue. I'm going to equate, because I want to find optimum value, means that the relative extremum value. So I have to equate this to 0. So as you know that dAdr, this will be equal to 0. It's not because of the denominator, it's because of the numerator. Alright, if you equate everything here equals to 0, means that the numerator is 0. So means that 4 pi 100 minus 2r power of 2 is equals to 0. So you divide both by 4 pi. 4 pi is a constant, it's okay to divide. So 2r power of 2, then you will have 0, right? You will have 0, and 2r power of 2 will be equals to 100. And r power of 2, of course, is 50, right? So r square, so 100 divided by 2, you have 50. So r is a positive, so you don't put plus minus, because radius is a radius, right? It's represent radius. So we only take the positive value. R is 50. So if you calculate, you are getting 25 times 2, right? 25 times 2. So simplify in the third form. So you have square root of 25 multiply with square root of 2. And last you have your r to be square root of 25 is 5 square root of 2 cm. There is only one value of r, right? After you find this is only one value of r. So for sure that this will give you a maximum area, right? Maximum area. So means that if you want to do the second derivative test, you were tested that either you use first derivative or second derivative test, you will find out that this will be the minimum value, alright, the minimum point, alright. So means that when r equals to 5 square root of 2, the area, right, the area. So the formula for area just now is area equals to 4 pi r square root of 100 minus r square. So means that the value of r for this value will be causing the area for the curved surface here to be a maximum area. Alright, maximum area. So that's very important. So I have show you that so with this value of r, the curved surface area will be maximum. Alright, so that's all for this video.